Hello everyone, this is Mrs. McCrory, and today we are going to continue talking about how to find the greatest common divisor, the greatest common measure, or the greatest common factor using that division method that we talked about from Pure Mathematics last week. Now, as you can see, I've listed that it can be either referred to as the greatest common divisor, measure, or factor. It's always talking about the same process of looking at a fraction and trying to find the biggest number that will go into both the numerator and the denominator so you can more easily reduce it into simplest form. So we are going to start with that division method that was in Pure Mathematics we talked about last week and this week in Elementary Treatise sections 61 and 62. Now when you start with this division method, we're always dividing the smaller number into the larger number. In all of these examples and all the examples in your texts, the fractions have been given to you in a proper fraction form. Just be aware that even if you have an improper fraction, you're still going to be dividing the smaller number into the largest number. Because if you're looking for the greatest common factor, clearly your factor can't be larger than your smallest number. For example, in this case, 36. So we have 36/60ths that we're going to start with. And hopefully at this point you can already see some common factors, but we're still going to use that division method and hopefully explain a little bit more why that method works. So we're starting with 60 divided by 36. See how many groups of 36 we can pull out of 60 and how many are left over. So we can see that there's 1, 36, we subtract and get 24. Now we know that we can pull out a section of 36 and that's going to leave us with 24 extra. So we now know that our greatest common factor cannot be more than 24 because whatever our greatest common factor is going to have to come out of this group of 36. It's going to have to fit into that 36, and we know if we've taken out 36, whether it is 3 groups of 12 or 4 groups of 9 or anything like that, if we take out a unit of 36 in any form, there's going to be 24 left over. So now we need to be working with this 24. So we're going to divide by our 24. 1, and this leaves us with a 12. Again, we know that the 24 can come out of this 36 in any form. You know, this 24 over here, we can use any form that we want, but now we're going to have a set of 12 left over, and so now we need to be dealing with the 12. And pretty clear to see 24 divided by 12 is 2 and 0. Now hopefully you already knew that the greatest common factor was 12, but hopefully going through it with those smaller numbers you could see why this division method works a little more clearly. Now to the purpose of why we're finding these greatest common divisors, these greatest common measures, we are going to be using this information, as it says in section 63, to reduce our fraction. So now that we know the greatest common factor, the greatest common divisor, we are going to divide that out of both our numerator and our denominator. And in this case, that's going to leave us with 3/5. So that is the purpose of all of this. You find your greatest common divisor so that you can reduce your fraction more easily. Alright, so another problem, we have 135 over 290. You can see I've already done all of the division here. We divide 135, or 290 divided by 135, 270, subtract, and that gives us a 20. So now we bring that over here and divide. 6, 120, we subtract and get 15. Over here and divide. 1 and it turns out that our greatest common factor is 5, which, using our divisibility rules from last week, should have been pretty obvious, but this way lets us know that it really is 5. It's not 25, it's not 30, it's not some other multiple of 5. It is just 5. And again, to reduce our fraction, we would divide by 5 over 5, because when you have the same numerator and denominator, this value is 1. It's equivalent to 1. And when you're dividing by 1, it doesn't change the value of your fraction as a whole. All right, so now we're going to look at something a little bigger. Here, again, we can very clearly see that we can take out a 10, but as you can see when we do our division, 420 is actually the greatest common factor between these two. So if you had started with 10, because it was easy to see, that would leave you with 42 over 504, and then you might take out a 2, and then you might take out, you'd be going through all these different steps, when in this division method, you found out that 420 actually was the greatest common multiple. So it seems like a bit of a hassle when we end up with, our greatest common factor is 5, but there will be times when it does definitely save you a lot of time and effort as you find that your greatest common factor is something much larger. So again, the purpose of this is to reduce our fraction. Oops. And that gives us 1/12. So hopefully that explains everything a little bit clearer. You can understand the concept a little bit better of finding the greatest common divisor using that division method, and you can work yourself through the division a little bit easier. The division itself is not any different from long division. You just have to remember to keep dividing until you don't have a remainder left, and that is finally your greatest common factor. If you have any questions, you can absolutely write them down and we'll discuss them at the live chat. You can use the forums and help each other answer each other's questions, or you can always email me and I will answer your questions as best I can on email, or we can schedule some additional time to talk through any meeting or Skype or anything like that. So please let me know if you have any questions. Until then, blessings in all of your activities, and especially your math. And I will, if I don't talk to you before then, I will see you at our live chat.